Okay, fine, everyone. So today we'll try to start with introduction to some basic terms, all of you. And whatever we have discussed till now, hope you will work accordingly, everyone. And yes, we'll be discussing about those tasks, whatever I have discussed about Power BI and Tableau as well. But now people, I think some of you have submitted the tasks. Those who have not, just work on that and submit it as well. Okay. Whatever the task which I have shared yesterday, you can maybe if you want, you can go with Power BI or Tableau. It's up to you. Okay, fine. Now see everyone, we will start with the basic concept. So I will just try to list down some of the terms, everyone. One by one, we will go and we'll talk about these basic terms. Okay. First of all, we will try to see what is AI. I know that many of you, obviously, every one of you have heard about this particular term many times, right? Artificial intelligence. So here I am not going to talk about the definitions actually. I will try to discuss these terms in such a way that everyone should be able to understand the meaning of this particular term. I'm not saying a definition or a definition which you can find out in a big book or on the internet. I'm trying to talk about this term in some sense which will make you understand this. Okay. Obviously, AI itself is very, very vast, but still we'll try to go and we'll try to talk about that particular thing in a simple language. Then we will try to talk about something called as machine learning. Again, if someone is aware about all these terms, definitions, I know you might have come across many times, but everyone, I'm just trying to make it simple. So just be there, listen, and then after that, if you have any questions, you can always ask. ML, everyone will try to talk about machine learning. And we will try to discuss about these terms in such a way that we should be able to differentiate between them. Okay. So ML is nothing but machine learning, and yes, one of the most important things which is a very, very important part of artificial intelligence, I can say, is nothing but deep learning. So whether you talk about artificial intelligence, machine learning, deep learning, everywhere you will see that all these terms are somehow they are related. Okay, and along with these things, everyone, yes, there is something called as data science as well, right? So obviously our focus will be on data science and machine learning, but as these terms are related to something like artificial intelligence and deep learning, in that sense, then we'll try to discuss all these things. Okay. So data science, obviously, we are going to explore more. Machine learning as well, we are going to explore more here in this session and in the coming sessions. Along with these, there are other terms as well, like something like natural language processing or something like computer vision. Everyone you might have come across something called as computer vision, natural language processing. Yes, they are also there. So both of these things, natural language processing and computer vision, they require the basics of machine learning, deep learning, or data science. How that we will try to see. Fine. So to start with, everyone, maybe you might have come across one diagram, something like this, which generally differentiates between all these terms. Something like this one, you might have come across, right? So let's suppose everyone, this particular circle represents artificial intelligence. Now, what is AI? If you just go, if you check this on the internet, everyone, definitely you are going to get a lot of definitions of artificial intelligence. But in simple words, everyone, if I want to define what is AI, I can say that it is something which enables computers, or in general, even it enables machines. So AI or artificial intelligence is nothing but to enable machines to think like human or to work like human brain. Okay. To think like a human brain or human. So to enable machines to think like human. In short, everyone, that's what AI is. That's what AI is. Or I can say another definition of AI can be like it's nothing but which with the help of which we can create something called as artificial brain. Okay, I will talk about this particular term, what I mean. Artificial brain. So something which can go and which can make use of something called an artificial brain. In short, AI is, that's how I can define it. I know that there are a lot of standard definitions here which are available. One can go, one can read that, or one can go and one can see in the like on the internet as well. But in simple words, even AI is nothing but to enable computers to think like human. And AI is the bigger umbrella of it. It means whatever it is there that will come inside AI. So even whatever we have discussed till now, it's actually a part of artificial intelligence only. If you talk about data analysis, yes, it's a part of AI, you can say. Because for going and for working on the projects which come under artificial intelligence even, obviously they are also going to require data pre-processing, data cleaning, data analysis and all those things. Yes, those are also the part of AI only, right? So in short, I can say that AI is nothing but to enable computers to think like humans or human brain. Talking about the next thing, if you're machine learning, which we are going to explore here in the coming sessions. So machine learning, I can represent something like this. I told you already, many of you might have come across this particular diagram somewhere, or maybe in some books. Okay. So machine learning is a part of artificial intelligence. I told you already that AI is the bigger umbrella. Everything is going to be there inside AI. Like machine learning is a part of AI, or I can say machine learning is a subset of AI. If I want to again define machine learning, so again you go, you check out machine learning. There are a lot of definitions available, but in simple words, even if I want to define machine learning, I can say that it's a bunch of tools. It is just a bunch of tools, or I can say, to be more precise, even I can say that it's a bunch of statistical tools. It's a collection of statistical tools, or it's a bunch of statistical tools. For what? For learning, to learn. From what? From data. So machine learning is nothing but bunch of statistical tools to learn from data. What is data, everyone? Data we have already seen, right? Data is a raw material. Information is nothing but the processed data. It means, everyone, if you might be an expert in all these techniques, all the tools, all the languages, but if you do not have data, you cannot do anything. And that's why data is obviously always required and is very, very important. Without data, nothing is possible. That's why, even if you remember, we already seen when we discussed about even databases as well, or when we started with SQL. You might remember we have seen something called as what is data, what is information. We already seen that. Okay. So machine learning is a bunch of statistical tools to learn from data, and data is nothing but raw material. Information is something which we call it as processed data. Now there are different types of machine learning, which we are going to talk about in a while. Okay. But try to understand machine learning is just a bunch of statistical tools. Now, what are these statistical tools, everyone? What are these statistical tools? To see, if I want to go and if I want to list down some of the statistical tools, maybe I can list down it like this. See, let's suppose I will list down here even. Whenever I say statistical tools, what I mean by that. So again, it is not compulsory that these are the only statistical tools which will require for machine learning and data science. Maybe more than that also can be required even. So statistical tools like what? Probability. See, if I am saying probability, it doesn't mean that you should be an expert in this. At least the basic thing, basic concept you should be knowing about even, which will help you to understand the algorithms and the techniques. So whenever I say it's a bunch of statistical tools, so statistical tools include something like probability, something like linear algebra, everyone, which you might have come across in school days, right? Some equations, something like matrix algebra, you might be having about idea about matrices, right? Matrix algebra, you might be doing a very simple rule like to multiply two matrices. What is the basic rule? Number of uh, columns in the second matrix should be equal to number of rows in the first matrix. I hope you might be doing about it. If not, otherwise, anyway, we'll come across this. Whenever we come across this, I will talk about it. It's a basic rule of matrixing. Okay. So I'm just giving you an example. So statistical tools means it can be probability, linear algebra, matrix algebra. Sometimes everyone maybe something, if you are aware about something like numerical optimization. Okay. I'm not saying again, always you are going to come across something like this, but sometimes you might require. And obviously, last but not the least, some programming language as well you might require even. So probability, linear algebra, matrix algebra, numerical optimization, and some computer programming language. Like here we have discussed even about Python, right? But again, it is not only Python. One can go, one can make use of some other language as well. But Generally, Python, because of its advantages, even many people prefer Python. But it is not like that. There is only Python. There can be other languages as well. So I'm just trying to give you an overview about all these things. It can be Python, it can be R, it can be C, C++ as well. With some, obviously, with some disadvantages or less number of features, maybe you can go with Java as well. Sometimes we can use, but mostly these two languages are used. And in that two as well, Python is preferred for data science and machine learning, right? Most of the times. And even right now, everyone, you might be knowing about something like Ruby as well. Even if some other new language, maybe if it is coming in future, fine, but basic things are not going to change. Okay. So these are the statistical tools. Even whenever I say bunch of statistical tools, I mean to say these are some of those statistical tools. Probability, linear algebra, matrix algebra, maybe mean, mode, median, even measures of central tendency, measures of variability, right? Those things also can come into picture here under statistical tools. So machine learning is a bunch of statistical tools. Coming to the next thing, everyone, that is nothing but deep learning. So deep learning is a small area, all of you, which comes inside machine learning. You can see here deep learning is a part of machine learning, which in turn is a part of artificial intelligence. And again, deep learning itself is vast. Each one of these is vast. No one can say that, okay, I know everything about artificial intelligence or I know everything about machine learning or deep learning. Not at all possible. Not at all possible. Each one of these is vast. You might be a PhD or double PhD even. No one can say that I know everything about it. As and when you go, you use it, you will get some experience. People will become expert in that. Right? And obviously, domain-wise, lot of things are going to change. Okay. So each one of these is vast. Now, talking about this particular term, deep learning. Again, you go, you check it out. A lot of standard definitions are there for deep learning. But just to give you an idea about something called as deep learning, everyone, deep learning is all about making use of something called as neural network. Okay, right. This particular term again, neural network. It makes use of the term neural. Okay, neural means what? It is actually taken from neuron. So as you people are aware about, even as a in human body, right? Human brain, human body, there are neurons present. It is because of neurons only that we are able to send the signal from one part of the body to another part, or from one neuron to another neuron. I hope everyone knows that, right? So that is a biological neuron. Whatever is the neuron which is there in the human body, everyone, that is biological neuron. So what scientists or researchers wanted, basically, the way biological neuron works, the way human brain works, they wanted machines to work the same way, right? So they tried to come up with something similar to what biological neuron is. Biological neuron, everyone, I think you might be aware about. Everyone, maybe if you go and if you check it out, see, just as we are talking about this particular term, all of you, deep learning, but anyway, at least as a general idea, see, if I go and if I try to talk about neuron, okay, or biological neuron, it looks something like this. This is like, you can say this one, right? Dendrites, which you are able to see here, or this one, if you can check. So see, this is a neuron, which is having something, this white part is called as dendrite, and again, which is responsible for sending the data from one part to another. Obviously, we are not going to going to the details of this particular part even, but I'm just trying to tell you how these things have actually explored from where it actually has come. Okay, so this is a neuron. So what scientists wanted, even they wanted something which will work similar to human brain. And human brain consists of not only human brain, actually human body consists of a lot of neurons. Those are biological neurons. See, it is because of neurons only, right? We are able to send something. We are able to send the signal from one part of the body to another part. So the way, and we are able to make decisions depending on a specific situation. Just take an example, everyone. Whenever we are driving, let's suppose, if you see a red light, obviously you will stop. Or if you are driving, let's suppose you will see a speed breaker, you will slow down the speed. So we are making the decisions depending on the situation. So scientists, researchers, they wanted something similar in case of machines as well. They wanted some mechanism which will help machines to, which will help them to train the machines the similar way the brain works. Okay, so that's why everyone they tried to come up with something called as artificial neuron. Okay, artificial neuron. So this neural network is nothing but network of artificial neurons. Generally, when if someone is going to read about deep learning as well, everyone, if you go and if you read, you will see that, or maybe those people who will be there till the end. I generally talk about deep learning as well. At least I give introduction as well, but maybe those over there they will understand. Neuron, artificial neuron area generally be represented like this. So what happens is generally here also we try to train the machine in some way. There will be some input we are going to pass, input data we are going to pass to some neuron, basically, and those neurons are divided into different layers. This particular layer is called as input layer. There are some middle layers which we call them as hidden layers. There can be more than one hidden layer, and there can be more than one neuron inside the hidden layer. And let's suppose this is the output layer. Okay, so what happens here, even as in human body, all the neurons are interconnected. So similar way, these neurons are also interconnected. Okay, these neurons are also interconnected. If let's suppose there are, let's say there are, let's suppose two neurons, biological, artificial neurons in the input layer. So again, this neuron will be interconnected to all of these. This is how it is going to happen. Okay. So this network of neurons, everyone, is called as neural network. At least this will help you to understand why I said that it is deep learning is something which makes use of something called as neural network. Okay. Anyway, this is not a topic which we'll explore here even. We'll be exploring data science and machine learning, but I'm just trying to give you some idea about it. Okay. So yes, this is what it makes use of everyone. And talking about different types of this deep learning, everyone, there is something called as artificial neural network, which is really good for numerical data. Okay, which is very good for numerical data. Then there is something called as convolutional neural network, which is really good for something like image data, everyone. And recurrent neural network. This is, if I want to give an example of this one, everyone, recommendation engines. It makes use of one technique that is called as LSTM, long short-term memory. As a human, everyone, we also have short-term memory, right? Human brain also has short-term memory. Let's suppose all of you, today I am talking about some concepts, right? Maybe those who will revise, those who will read, they will be able to remember, let's say for 2 days, 3 days, 10 days. Maybe after that you will forget. Short-term memory, right? So something similar is actually used in case of recurrent neural network. All these things are really very interesting, even, but yes, one needs to spend some time learning all these things and trying out. Okay, so long short-term memory. The best example of this one, everyone, is recommendation engines. Recommendation engines, everyone. A very common example which you people generally make use of, right? See, if I go here, let's see if I try to show a simple example, even see. Let's suppose I will try to search for something like India. So can you see here? It is suggesting me India live match tagwood. So how can we know that? It knows that something like this, right? It is recommending. It is recommending me. If I try to search something like this, right? Let's say Sachin, I will search. You will see it is suggesting me all these things, recommending. Or for that matter, any example you take here. Netflix, you search for one movie. Let's suppose you are searching for action movie. It will suggest you 10 to 20 other action movies. Recommendation. Flipkart, Amazon, a lot of examples are there even, which can come under recurrent neural network. Okay, so long short-term memory is what basically makes it. I told you already here, this is just a basic idea about all these things, right? So deep learning, if I talk about it, this is very important area, because if you people are reading in general, if you are reading about, if you people are having a habit of reading some technical articles, generally you might have come across something called as Google's AI. You might have come across something called as Google's AI. Google's AI, maybe by chance, if someone has read about it, everyone, you will notice that most of the things in case of Google's AI basically are dependent on deep learning systems. That's how it is very, very important about it. And if you talk about, let's say, you talk about, let's say, last few years, let's say last 10 to 13 years, you will see that most of the work in this artificial intelligence system is being done in this, is actually being done in this small area that is deep learning. That's how it is very, very important. But again, we talk about AI or ML or DL. Each one of these is vast. As I told you, you need to spend some time and you need to understand about all these terms through hands-on examples, through reading, right? And trying out the things. Okay, CNN, sir, CNN is nothing but convolutional neural network. Convolutional neural network, it has been seen that it works really well with image type of data. It works really well with image type of data. So here, it doesn't mean that CNN should be used only for image type of data. It can be used for text data as well, but it gives high accuracy for image type of data. If you create a model, see everyone, if I create a model means what? Here itself I show example even, and that too of CNN. See, if you want to know about that, or maybe even you can go and you can check even. See, as I have already created something like you might be knowing about even. See, yeah, see, here it is, right? If you search with my name, teachable machine Yogesh Paramkar, I already created. I have not created actually, I just used which it was already there. Let me show it to you. You will see. Here I am talking about that example because just want to show you even what is that model in C. Even you can also create this even. See, what I done is, see, this is a simple example. You can say something like this is happens in of CNN. What am I doing here even? I am taking some images of myself and then I am going to see, I am going and taking some samples through different angles actually. So I am going to pass these images to the machine. So I was having a Bluetooth speaker actually. I've taken that Bluetooth speaker and I've taken the images of that Bluetooth speaker and I've taken the images, my images I also taken. And then those images everyone I passed it to machine. See, this is ready-made even. I simply passed it. I did not do anything actually. So basically, I'm trying to teach my machine that okay, this is Yogesh Moramkar and this one is Bluetooth speaker. So I'm just showing it. I'm just showing it one image, two image, three images, four images, five, six, seven, and so on, 100 images. So as many number of images I'm going to show it to the machine, everyone. You will see that my model is going to become perfect in that, or the more accuracy of my model is going to increase. You can see everyone, this is what I am providing it to my model. This is what I am providing. So as I told you, I have not written a single line of code here. I am simply going and just taking the photos in from different sites. See that Bluetooth speaker is there, and I am just trying to take the photos of all these things. And after that, everyone, what I have done is, maybe many of you might have seen this teachable machine. If not, you can even go and you can try out. This is one example. Like this, here I had done it for Bluetooth speaker, and let's say my image. You can go and you can do it for any other thing. Let's say water bottle, or let's say keyboard, right? Anything if you want. And now see, just if you pass the images, I have passed 102 images of Bluetooth speaker, and I have passed 109 images of myself, and I clicked on train. Now this will give me a model. This will give me a model. Now to test that model, what I will do is I will come in front of the webcam here, and then it should detect whether it's Yogesh Maramkar or whether it's Bluetooth speaker with some accuracy of it, right? So see, this is training. Anyway, I'll be showing it to you even how the training is and some machine learning. But just to make you understand about some terms that okay, I was using something called as model. See, can you see everyone? Yogesh, that 100% it is showing me because I am in front of the camera. I've just on my webcam, and you can see as I was in front of that particular webcam, it has detected that okay, it's me. So see that name I have circled. And as soon as I bring Bluetooth speaker in front of that particular webcam, it will tell you that, okay, it's a Bluetooth speaker. So what I done, I shown the images to the machine and my machine is trained. Even one can download this particular model. That is anyway, we are going to see how to go, how to download it, what is the extension and all those things. We'll be talking about it. But as we were talking about something called as deep learning or CNN, you asked sir, right, about CNN. So see, image data is what I have passed, and I simply clicked on it. Obviously, in the backend, something has happened. If you want to see what has happened in the backend, that also this particular teachable machines will give you. In the backend, it is going to create the code. In the backend of you, it is going to create the code, and that code you can download and you just, and if you are aware about some basic packages and Python, and if you talk about deep learning, some frameworks, if you are aware about like TensorFlow, you can go, you can make the change in that code and you can have your own model as well. That's why when I said that it is not necessary that you should be an expert. You should be an expert in the language. You should know basic things and some packages you should know everyone. And obviously algorithms are going to play a very, very important role. Okay. And now see all of you, as I told you that you can even go and download the code which is generated here. If you go and if you click on this export, like I think I show here. See, I clicked on export and now see everyone. You can get the code with .js or .py, whatever you want. You can get the code here. See, Keras underscore model on H5. So this .h5 is a model, everyone, which is trained. .h5 is like an executable file. So we have not done anything. See, I had taken the code from here and I am copy pasting it in Jupyter notebook. Just check this out, everyone. So this code is automatically generated. Okay. So all these things I just try to talk about even because I just wanted to give you an idea about what is a model. This is a model, everyone. Obviously, one can make use of the models in different ways. We'll talk about it. We'll definitely go and we'll talk about it. Even. But yes, this is one example I can say. This is an example of a model element which actually is making use of something called as convolutional neural network. Okay, I told you, right? We haven't discussed about it. I'm just giving you an example so that you will have a basic idea about what are all these things. I think you are getting my point of view, right? CNN, right, sir? I think convolutional neural network, basically used for image data. Later on, you people can go and definitely explore. Okay. But yes, at least ANN, CNN, RNN, and these are nothing but you can say approaches or the types of deep learning. Okay, that is one thing. Now moving to the next. See, we discussed about, in short, we discussed about AI, ML, and DL. Now there is a more thing, even as I said that which we are going to explore, data science, right? So many times, many of you might have seen that in many books or many people generally write it down like this: data science and AI. You might come across that in such a way that data science and AI, they are overlapping with each other, right? Fine, that is also right. But to be more precise, everyone, data science can be represented something like this. And if you ask me again, what is data science? You go, you check it out. A lot of definitions are there even. But in simple words, I can say that data science is simply, I can write it down as understanding data. In simple words, everyone, data science is all about understanding data. Or I can say that making sense of data. Okay, simple thing. I'm just trying to define it in very simple words. Making sense of data or understanding data is nothing but data science. And yes, definitely, you are going to come across something called as visualization or visualizing. Visualization is one of the most important aspects of data science. Not only data science, actually. You talk about data analytics as well. I told you already, right? Data analytics, data analysis is actually a part of all these things. So visualization is more involved in data science as compared to machine learning. Otherwise, data science, machine learning, you will see a lot of things are similar. That's why there is overlap, right? But try to understand it. Whenever I say visualization is very, very important aspect whenever you talk about data science, it means what? Visualization you can do with the help of Python. Maybe you can do it with the help of Excel. You can do it with the help of Power BI. You can do it with the help of Tableau as well, or maybe any other tool as well. Maybe even you can get some idea about or analysis about your data through SQL as well. So it depends which type of tool you want to make use of it. But yes, visualization is one of the important aspects talking about data science. It doesn't mean that it cannot be used in other fields. Definitely, it can be. But mostly, if you talk about data science, and data science is all about understanding data, making sense of data. So data science, right? We are going to make use of data along with some domain knowledge about that particular data, and we can utilize it maybe in model development, maybe in only analytics, decision making, forecasting, and so on. What type of problems can be solved? We'll talk about it. Whenever I'll be talking about machine learning, everyone, you will see that those things are there in data science as well. Along with that, it has some extra things as well, somewhat related to visualization. So you can clearly see everyone that data science is having an overlap with artificial intelligence. It is having an overlap with machine learning. It is not having that much of overlap with deep learning. But you can see this is what the whole picture is about. In short, this is how I can say that one can understand about all these stuffs. Obviously, as and when you will read about it, or anyway, you are going to come across all these stuffs again and again, the things will become more clear everywhere. Okay. So I hope all of you are able to understand these terms, right? Anyone any doubt here? Any question? Anything you want to add? Is it clear, everyone? Whatever we have discussed, artificial intelligence, machine learning, deep learning, data science, all these things. Okay. I hope others are also able to understand that. And talking about something like NLP as well. So I told you already, maybe generally those who will be there till then, you will definitely come across some NLP projects as well. But again, it requires patience. Okay. So I told you already, remember one of the participants actually he done NLP, 1 or 2 NLP projects properly, and he got really good opportunity actually. Anyway, those things will come across later on. But NLP, if you talk about even natural language processing, you will see that I can represent NLP something like this. NLP will be making use of all these things, or even computer vision as well. Those are like computer vision is again uh, dealing with image data, image processing. You might be doing even sometimes you will come across hardware as well. So we used to do some projects earlier even, right? With some hardware as well, something like if you people are those who are from some background, let's say maybe those who are from engineering background, maybe they might be knowing about some hardware devices as well. So how to go and how to incorporate a model, machine learning or deep learning model into hardware even. You, that is possible or not. So as this is just the start of artificial intelligence even. Robotics is the best example of AI. So hardware is there, right? Self-driving car everyone. Artificial intelligence only. So whenever I say artificial intelligence, it means all these things are huge. Deep learning, machine learning concepts are huge, definitely. Okay. So you might have come across a lot of things here. Like if you talk about CCTV cameras, CCTV cameras, they have the features of detecting some anomalies. Anomaly means what? Something unusual. Let's say in front of CCTV camera, two people are fighting. So it is something unusual, right? So maybe there might be some models which can go, which can detect that, and maybe there can be some alert or something like that. That is possible. So I mean to say, even models can be deployed into hardware as well. That is possible. Even models can be used in mobile applications as well. Obviously, there will be some people from some specific domain of with some specific skills they will also be required, obviously. But I'm just trying to talk about the possibilities. Okay, so don't worry about that. Like, okay, does it mean that you should know everything? No, I'm just trying to make the things clear here. So don't worry. Uh, I'm just trying to give you an idea about these terms. Generally, I have seen people even uh, fine. You people get job, they will work. they will get salary and all those, that is fine. But uh, if someone wants to learn something new again, definitely you need to spend some time. Okay. And specifically, if you talk about something like deep learning and all, yes, he can try many times you need to do it. Okay. Fine. Okay. I hope at least the basic idea you have got about all these stuff. Now, as we are going to focus more on some of the terms like data science and machine learning everything. Okay. And as I said that, and as you have seen that data science and machine learning, they are overlapping with each other. More or less, everyone will see that they are same. Because visualization anyway will be used in data science as well as machine learning. Along with that, in case of machine learning, we have some algorithm. So everyone, what we'll do is we'll try to explore this particular term, machine learning. Okay. We'll try to explore this particular term, machine learning. See now, as we have seen, machine learning is a bunch of statistical tools to learn from the data. Now there are different types of machine learning as well. Or to be more precise, I will not say types. I will say that there are some approaches of machine learning. Like you might have heard about it. There is something called as supervised learning approach. So try to understand the meaning of this term because the problem statement which we are going to come across later on will be divided into one of these categories. Always remember that. Okay. The first category or the first type or the approach of machine learning is supervised learning. Then obviously, if supervised is there, then there must be something like unsupervised. So the second approach everyone is nothing but unsupervised learning. Okay. These terms after this point onwards, even you are always going to require. Third thing, generally you might have, if you people are reading some books, those who have interest, if they are going to read some books after this, or maybe on the internet, if you find out again, you will see that generally they will list three types of supervised, unsupervised, and something called as reinforcement. But there is one more even that is called as semi-supervised as well. Why is it that I will talk about it? Okay, semi-supervised learning. And then the fourth type is also there even that is called as reinforcement learning. So these are the four types or approaches of machine learning, we can say. And accordingly, with them, according to these types only, the problem will be divided into different categories. Now, see, supervised learning. Why the name is like this, you will come to know about it. Supervised, that means there is some supervisor, okay, who is going to keep some eye. All these things even we are trying to understand because later on we are going to train the machine to enable computers to think like human brain or to work like human brain, artificial intelligence. So we are going to train the machine, but to train the machine, everyone, there are different approaches. When to use what approach? If you want to understand that, for that you should know what is the meaning of this all approaches. So supervised learning approach even is always used for labeled data. At least you remember this. Supervised learning approach is always used for labeled data. Now, what is labeled data? Or before that, machine learning. This term, what is the meaning of this? Machine is learning. Machine is learning from where? Machine is learning from data. Machine is learning from data, which we show it to the machine. Very simple thing, everyone. If we try to correlate this particular thing to the way we have learned or we have been learning from our childhood. In the childhood, everyone, right? See, why it is called as supervised learning? Because there is some supervisor. So who was the supervisor when we learned the things in our childhood, everyone? Let's say when you people learned or when we learned about ABCD, we learned it from our parents or teachers, right? So they showed us that, okay, this is A. They told us that this is A. Then they told us that this is A. Then they showed us this one and then they told us that this is A. So they showed us different pictures. They drawn it and they tried to tell us that, okay, this is A, and A. So this is our training area. And once our training is done, they try to test They were asking us, now tell me, is it A? So if you say right, that means your training is done well. If not, once again go, once again you will get the training or you will study, and then once again you will try to understand, and then again test will be conducted. So everyone in that case, there was a supervisor, teacher or parent was there, right? That's why that particular name is supervisor. So on the similar hands, even something similar is going to happen in case of machine learning. Here as well, what's going to happen? Same thing. We are going to show some data to the machine. That data can be text data, numerical data, image data, video data, audio data, depends on the problem set. So supervised learning, why I've written it like this even? Supervised learning is always used for the data which is labeled data. Now, what do you mean by label, everyone? Always remember after this. See, let's suppose I want to create a model which is going to predict salary of the person based on, let's say, based on year of experience to that person, based on his interview score, out of 5, how many marks that particular person has got, based on, let's say, written test score. To see everyone, what's going to happen is, basically, you are always going to get some data, which is historical data. Okay. So let's say we have data of 1000 people. Okay, 1, 2, 3, and so on. 1000 people already we have. We have all these things for them. Year of experience, let's say 2 years. Interview score out of 5 is, let's suppose, 4. Written test score out of 5 is, let's suppose, 3. So he was given the salary as, let's say, 50,000. So like this, even we have the data of 1000 people. Earlier data, historically. Now we want to create such a model which is going to predict what should be the salary given to a person with 3.5 years of experience and the marks like this. So this is what our model should answer. Something like this we want to create. Okay. So here everyone, these three things, year of experience, interview score, and written test scores, these three things everyone, they are called as inputs. And this particular thing is called as output. That means we have been given what is the input and what is the output. From these data, we want to train the model. So this output, everyone, is also called as label. So whenever the output is given, it is called as labeled data. Supervised learning can be used in case of the models where you have labeled data. This is called as label. Output is called as label. It is also called as a response variable. Output is also called as response variable, or it is also called as target variable, or it is also called as dependent variable. Okay, or it is also called as explained variable. Input variables are called as independent variables. Okay, or they are also called as explanatory variables. Output variable is explain variable. Input variable is explanatory variable. So input variable or input independent variable, explanatory variable is nothing but these inputs. And output variable, target variable, label, response variable, dependent variable, explain variable is output. If possible, remember these terms. Okay. So are you getting my point? Supervised learning approach should be used in the case where you have labeled data. It means it should be used where you are aware about what is the input and what is the output. Here you know that salary is the output and these are the input, label data. You know about the, you have an idea about label. So for those kind of problem statements, you can use supervised learning approach. Other example can be, let's suppose I want to create such a model which is going to predict how many runs a player is going to score based on history, based on previous data. So we know what is the output here, how many runs a player is going to score in the next match. So we know the label. That can be done with the help of supervised learning approach. Always remember, even you will be given some data to train the model, okay? And that data should be proper. And to make that particular data proper or clean, you need to make use of those data cleaning, data pre-processing, data visualization, tools, languages, SQL, whatever you want, you can go, you can make use of. That's why all those things are required in data science and machine learning projects as well. Try to understand that. Is it clear, all of you? What is labeled data and when to use supervised learning? Anyone, any question here? Those people who are bored, I think they left. 1, 2 people, I think, left. Those who are there, those who are listening me. Supervised learning, is it clear? See, I told you already, you decide, okay? You want to go only in tools. Definitely, with the help of that, you can go in analytics. But this will also help you in analytics as well. Not try to understand. Generally, people don't be that much of stress, but this will help you. This is very important actually. Maybe right now you will be getting some job, but in future, definitely, if someone is aware about something like this, someday or the other, definitely this will happen. Okay, you will definitely see that. Hope that is clear to you. Okay, next thing. So, fine. This is a simple example even. So, like this, these are called as prediction models here. Whenever we are going to predict something, these are called as prediction models. So, wherever we want to do predictions, yes, we can create the models for them. If I want to do classification, if I want to tell you classification type of problem as well, let's say I want to classify a patient as diabetic, non-diabetic. So yes, we are aware about output that also can be solved with the help of supervised learning approach. So one thing you remember, even supervised learning approach can be used for label data. People call it as parent-oriented learning, teacher-oriented learning. Why? Because supervisory learning. Okay. Now next thing, unsupervised learning, or maybe let me complete supervised learning. Supervised learning, everyone, as I told you, one can solve two types of problems with the help of supervised learning. One can solve two types of problems. So the first one is prediction types of problems. One example of prediction type of problem I already given. Prediction, or I can call it as a regression. Prediction or regression types of problems. Second type of problem which can be solved with the help of supervised learning, everyone. They are classification types of problems. Prediction is what? Predicting the salary of the person based on interview score, written test score, and the age or the years of experience. Predicting house price, predicting share market price, predicting how many runs a player is going to score in the next match, predicting how many marks a student is going to score in the next match, and so on. These are the examples of prediction model. Classification models, anyone? Whether the product is good or bad based on some features. Whether the patient is diabetic or non-diabetic, right? Or maybe you can go and you can have some other classification types of problems as well, depending on specific domain. Whether the quality is again good, bad, depending on some features, right? Pass, fail, yes, no. So classification types of problems. So both these types of problems can be solved with the help of supervised learning approach. I already given you the example. Fine. Now, to solve these problems, everyone, to solve prediction types of problems or even classification types of problems, you are going to require some algorithms. So specifically talking about prediction type of problem, the very basic algorithm which we are going to start with is something called as linear regression. Very basic algorithm we start with. Okay. And for classification, even one of the basic algorithms which we are going to start with is something called as logistic regression. Okay. And again, these are very basic algorithms. There are other algorithms as well. To solve prediction types of problems, even there is something called as decision tree algorithm. Then there is something called as ensemble techniques as well. We'll talk about it. Something called as ensemble techniques. And from decision tree and ensemble techniques, we are going to get a very good algorithm that is called as random forest. I'm just listing down all these things one by one. Okay, in the notes you'll be getting each and everything separately. Then there are other algorithms as well. Something called as naive-based algorithm also, naive or naive-based algorithm. Okay. Then there is something called as k nearest neighbor. Then there is something called as support vector machine. Okay. So like this, all of you will see that there are different algorithms. Something called as XGBoost, which is actually a part of ensemble learning technique, which is one of the best algorithms when it comes to prediction as well as classification. This is called as queen of machine learning algorithms. Extreme gradient boosting. It is actually, this is also one algorithm which is called as queen of machine learning algorithms. Okay. And talking about classification types of problems, yes, this decision tree can be used for both classification as well as regression. There are ensemble techniques, yes, can be used in case of classification as well. Random forest again can be used for classification as well. New base is also can be used for classification as well. KNN is also can be used for classification as well, and this is one of the best algorithms for solving classification types of problems. I hope you people are getting okay what is classification. What are the examples of classification types of problems? Even diabetic, non-diabetic, pass, fail. Okay. Support vector machine again can be used for classification types of problems. And yes, XGBoost also can be used for classification types of problems. If you see everyone, except first algorithm, all the remaining algorithms can be used for both classification types of problems as well as regression or prediction types of problems. Okay. So these are some of the algorithms even which we are going to discuss in detail. Algorithms or you can say techniques. Fine. Now coming to something called as unsupervised learning. In case of unsupervised learning, everyone, the data is unlabeled. It means what? It means we are not aware about what is the output. Let me give a simple example. See how. Let's suppose I have some data. Right. This is our original data. In this, you have lot of different data points. These markers, whatever you people are able to see, everyone, just imagine that they are different data points or records, rows, everyone you can say rows. There are a lot of records in this particular data, but you don't know what is the output. What output is actually, we don't have any idea about it. So it means you are not aware about the label area. Just imagine it like this here. You have a lot of marbles. You have a lot of marbles, right? But what to do with all those marbles? Maybe you don't know, right? You don't know the output exactly. So maybe one can divide those marbles depending on their weight, maybe depending on their size, maybe depending on their texture, maybe depending on the color and so on. Criteria can be anything. Let's say similar color marbles will be in one group. Let's say pink marbles will come here in this group. Okay. We are not aware about the output. Yellow color marbles will come in some other group. And then maybe let's suppose some other color, let's say green color marble will come into some other group. So here even, this is actually clustering. Clustering is what? Clustering is nothing but grouping. So unsupervised learning, everyone, can be used to solve clustering types of problems, as supervised learning can be used to solve classification and prediction types of problems, everyone. Unsupervised learning can be used to solve clustering types of problems. And to solve clustering types of problems, everyone, there are some algorithms. One of the very common and very important algorithms to which is actually made, which is actually used in real time as well, even is K means. K means clustering. Okay, this is one of the very commonly used algorithm when it comes to clustering types of problems. There is another very good algorithm which generally people do not make use of. Those who are aware about it, they make use of it. That is called as DB scan. So both these algorithms, everyone, we are going to talk about in clustering. Clustering is what, all of you? Clustering simply means grouping. See, we have grouped the data here, right? Zeroth group, first group, second group. So these three groups are there. After that, then whatever you want to do with that particular data, you can. But see everyone, unsupervised learning. It can be used to solve clustering types of problems. And for clustering, everyone, K-means is one algorithm and DB scan is another algorithm which can be used, which we are going to see. We are going to talk about these algorithms. Okay, fine. Hope you people are able to understand. And when you will see actual examples in the implementation, you know, definitely you will come across. Okay? As I told you, in these kind of things, some obviously more, some more patience is needed if you are not aware about these things, or if you have not come across these things earlier, maybe. So more patience is needed actually for some sessions, few sessions, and then you will be able to relate to this. Right? So whatever I am trying to tell you, you can just try to understand. If you have any question in between, just raise, let me know. Okay? So supervised learning, I hope it is clear. Unsupervised learning, I think you are getting my point. It is used for unlabeled data. It means there is no label. We are not aware about the output variable. We are not aware about the target. We don't know what is the response variable, explain variable. We don't know what is dependent variable. Okay. Now coming to the next one, even semi-supervised learning. Semi-supervised. It means what? Even it means for some records, you know what is the output label, but for some records, for some inputs, you are not aware about the output. Or in short, even what I can say is, what I can say is semi-supervised learning is nothing but unsupervised learning plus supervised learning. And I will tell you everyone in maybe in real-time projections, basically we use this one. And that is the reason why, as it is already consisting of semi-unsupervised learning plus supervised learning. That means supervised learning applied after unsupervised learning is nothing but semi-supervised learning in short. That's what I can say. And in real time, you will see that we generally follow this particular approach. That is nothing but supervised learning applied after unsupervised learning. Because again, this is the original data, right? Going and applying the algorithm directly on the original data is also not good. If you divide that into different groups and then you apply the algorithms parallelly, that will be done in a faster way. Parallel processing can be done. That is possible. So semi-supervised learning approach. Talking about reinforcement learning. Reinforcement learning is also called as feedback-based learning. Okay. Reinforcement learning is also called as feedback-based learning, or it is also called as feedback-based learning, or it is also called as reward-based learning. Now, why I did so? Feedback-based learning or reward-based learning. Why? Because see everyone, based on what is the final result you are getting, there will be some feedback which will be given. Just take a simple example of it. See, the best example of reinforcement learning is self-driving cars, robots. If there is a robot even, on the next instruction, it is supposed that it is expected that the robot should move one step forward, but it is moving one step to the right side. That means it is not performing the correct task, or as per the expectation, it is not performing. Give negative feedback. Punish it means we will be using some flag or variable even, and we set it to negative value. If it is doing the task properly as per the expectation, give positive feedback or reward it, so that it will remember that particular thing next time. That's why everyone, and from that it should learn, right? That's why it's called as feedback-based learning or reward-based learning. That's the only reason. Okay. And as I told you, all of you, self-driving cars, robots are the examples of reinforcement learning. But there are obviously the work in this particular area, that is reinforcement learning, everyone. It is increasing, and obviously in future it is going to increase. Right now, there are two companies like Google and Microsoft already working in this particular reinforcement learning. Okay? But reinforcement learning, if you talk about even that, will go out of scope of this particular course. We'll be making use of all these things. And obviously supervised learning, unsupervised learning, they are going to solve almost all the problems. This will obviously we come into picture with some hardware as well. Like I already given an example, right? Self-driving cars or something like robots. But anyway, to understand all these things, obviously one should have a knowledge about all the techniques, whatever we have learned, along with algorithms, and we use these particular approaches, whatever we have discussed. Right? So overall, everyone, these four approaches are the approaches for machine learning. I hope you will remember after this point, and you will remember the meaning of that and when to use what. I hope you will remember that. Supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. These are the four approaches, and their meaning also I am trying to tell you. Is this clear, everyone? Anyone in doubt till this point in whatever we have discussed? Any question, anyone? No? Fine. Hope that is clear to others as well, and everyone is able to understand, or everyone is able to make some sense out of whatever I have discussed. Okay, fine. Now I think we can start with the discussion on okay, what question is saying? Okay, what I want to okay, Neovis algorithm you was okay. Example on probability of playing cricket according to your condition. Yeah, so any question related to that, Toshan? Do you have any question related to that? Or otherwise, anyway, Neovis, anyway, we that was just a simple introduction. Okay, fine, fine, thank you. Yeah, again, but here we'll be going and we'll be implementing it actually. Okay, fine. Now I think even we are good to go with this one, linear regression. Okay, we are good to go with linear regression. First of all, understand the concept. In the notes, even you will find out everything. Okay, in the and I'll be sharing the notes for all the algorithms. Anyway, I told you, I'm just updating once again, and I will share it once, and I will tell you where to download all those things. Okay, but now I think we are good to go with linear regression. Linear regression is one of the basic algorithms to start with if you want to learn machine learning, let's say, or data science. With the help of this algorithm, we'll try to see how we can make use of all the things whatever we are discussing. Okay. Fine. Anyway, let me start with linear regression concept. So that at least we should be able to finish with the concept of linear regression, and then maybe in the next session we'll directly start with the implementation. Okay. So linear regression. Okay. Linear regression is a technique or the algorithm I can say. Linear regression makes use of equation of a straight line. I hope everyone might be knowing about the equation of a straight line, right? Y is equal to mx plus c. We have been learning this from the school day. Now here you will see the practical usage of that particular. Y is equal to mx plus c, where m is what, everyone? Slope. C is what? Y-intercept. What is the meaning of y-intercept? The point where it cuts y-axis. What is x? Input. What is y? Output. Input variable. Explanatory variable. Independent variable. Output variable. Target variable. Response variable. Label. Okay. Dependent variable. Some people write down this particular equation like this as well. Y is equal to beta 0 plus beta 1 x. Or anyway, some people write it down like this as y is equal to b0 plus b1 x. Any of these things is right in it. Okay. So now see everyone, linear regression is completely based on this particular equation. Now to explain you how linear regression can be used to create a model, everyone, and to understand some concepts, I will go with very common example where you have one input and one output. Generally, I go with this example. See, there is, let's suppose there is some data. We have some data about some movie. Let's say Bahubali Part 1 movie. We have some data about it. And Bahubali Part 2 movie. Okay, we have some data about this one. So let's suppose all of you, what we have is, we have ratings for this particular movie. Out of 5, how much was the rating given by first person? First person, second person, third person, fourth person, fifth person, sixth person, and so on. So how much was the rating given for Bahubali Part 1 by first person? Let's suppose out of 5, first person has given 4. And same person has given rating 3 to the Bahubali Part 2. Second person has given the rating as 2, 4. Third person has given the rating as, let's suppose, 3, 2. Fourth person has given the rating as, let's suppose, 5, 5. And the next person has given the rating as, let's say, 1, 3. And this person has given the rating as 3, 1. Obviously, this data should be very much, but for understanding purpose, let's suppose we have ratings given by 6 people. Okay. So just imagine everyone, or just assume that this is your X, that is input. This is your Y, that is output. Now what we want to do is, we want to create such a model which is going to predict the rating given by a specific person for Bahubali Part 2 movie if he or she use the rating as, let's say, 3.5 for Bahubali Part 1. So we want to create such a model which is going to predict what will be the rating for Bahubali Part 2 if a person gives rating as 3.5 for Bahubali Part 1. This is the model which you want to get. Obviously, I told you that there will be one input and one output. In real time, it is not going to happen. In real time, again, you are going to get multiple inputs and one output. But to make the things easy, to understand the things easily, we are just trying to talk about this particular example where you have one input and one output. So this X is your input and this Y is your output, or label, target variable, response variable, explained variable. That means it's a labeled data. That means, yes, I can make use of supervised learning approach, and linear regression comes under supervised learning approach. Okay. So we want to create a model. So for that, we want to, it means what, even this is Y. So we want to find out the Y value. And to find out the Y value, what we have is Y is equal to B0 plus B1x, where B1 is the slope and B is the Y-intercept. It means that even depending on the value of X, we want to find the value of Y. But to find out the value of Y, depending on the value of X, we need to find out something called as B1 and B0. If you are knowing about B1 is the slope and B0 is the Y-intercept given, to find out the value of B1, again, we will not go into the details that how we got this equation. To find out the value of B1, that is slope B1, the equation is like this. Summation x minus x bar into y minus y bar divided by summation x minus x bar whole square. Again, those who want to go into the details of the mathematics involved inside this, you can, but not necessarily. Okay. This is how one can find out the slope. This is the formula of the slope. Now, what is this x bar, all of you? X bar is nothing but average of x. What is the average of x? 4 plus 2, 6, 9, 14, 15, 18. 18 divided by 6. X bar is 3. What is the value of y bar? 7 plus 2, 9, 14, 17, 18. Again, I think it is same. So we got the value of x bar and y bar, all of you. 3, 3. Average. Simply average, everyone. So yes, that is the thing. So according to this particular equation, even I will try to find out all these values. This is my x, this is my y. I will try to find out x minus x bar. Why am I trying to find out even? Because I will need it here. Next thing, I will try to find out y minus y bar. Because I need it here. I want to find out the value of B1. That is slope. And then I need to find out x minus x bar whole square as well. Okay. This is another thing which we are going to need. Along with that, what else we need? Fine. I think we are okay. Multiplication of x minus x bar into y minus y bar. Right? X minus x bar into y minus y bar. That means that numerator again. That numerator I am trying to find out. Okay, this is x minus x bar. So fine. These are all the values which we will try to find out even from this value, and then we will find out the value of B1. So what is x minus x bar? X is 4, x bar is 3. 4 minus 3 is 1. X is 2, x bar is 3. 2 minus 3 is minus 1. 3 minus 3 is 0. 5 minus 3 is 2. 1 minus 3 is minus 2. 3 minus 3 is 0. Hope it is right. If it is wrong, let me know. What is y minus y bar? This 3 minus this 3, 0. 4 minus 3, 1. 2 minus 3, minus 1. 5 minus 3, 2. 3 minus 3, 0. 1 minus 3, minus 2. Right? This is y minus y bar. X minus x bar is what? Square of this. 1 square is 1, minus 1 square is 1, 0 square is 0, 2 square is 4, minus 2 square is 4, 0 square is 0. We want to find out what summation of x minus x bar whole square. That means summation of this 1 plus 1, 2, 8. This is 10. We got the summation as 10. This value we got as 10. Similarly, x minus x bar into y minus y bar. These two multiply, right? 1 into 0 is what? 0. Minus 1 into 1 is what? Minus 1. 0 into minus 1 is what? 0. 2 into 2 is what? 4. Minus 2 into 0 is 2. 0 into minus 2 is 2. And summation of x minus x bar into y minus y bar. What is this element? Minus 1 plus 4? 3. So we got this value here. So I can put those values here. What is summation of x minus x bar into y minus y bar? 3 divided by 10. That means everyone b1 is equal to what? 0.3. So I got the value of b1 as 0.3. And now what I will do is I will put that value here. Y is equal to b0 plus 0.3x. I want to find out the value of b0 now. So instead of this y and x element, we consider this as y bar and x bar. And what is the value of y bar? 3. What is the value of x bar? 3. So y bar is 3. Then 0.3 into x bar is 3. So from this one, you can get the value of b0. 3 minus 0.9. 2.1 is the value of b0. Your equation is going to become what? Y is equal to b0 plus b1x. So based on the value of x now, you can easily find out the value of y. Or as I want to tell you about some terms here, everyone, as I want to tell you about some terms, see what can I do is, I can draw, let's say, I can draw a graph here. Let me draw it properly. Okay, something like this, x and y. Okay, then this is x-axis, this is y-axis. What is x in our case? Rating for Bahubali part 1. What is y in our case? Rating for Bahubali part 2. So these are ratings are from 0 to 5, right? So 1, 2, 3, 4, and 5. Similarly, everyone 1, 2, 3, 4, and 5. So we have plotted this particular graph. Now 4, 3, x4, y3, somewhere here, not accurate, but somewhere here. Sorry. Okay. Then 2, 4, even 2 here, 4 here. Then 3, 2, 3 here, 2 here. Then 5, 5, 5, 5, somewhere here, somewhere here. And 1, 3, 1 and 3. So I'm just plotting those points here, and 3, 1. 3, 1 is here. So this is our original data. Obviously, I told you original data should be very, very big. But obviously, to understand, we have a small data. Okay. Now see all of you. What basically happens is through this data now, linear regression makes use of equation of a straight line. What we do is we are going to draw a line which will pass through this particular data. And that particular line will pass through this data in such a way that the distance of that line from all these points is as minimum as possible. Or I can say that that line is going to pass through dense area. That means where there are a lot of points. So suppose see everyone something like this I am trying to talk about. I want to draw a straight line passing through these all points, right? Now to draw a straight line, everyone, you require at least 2 points. One point is what? One point is x bar, y bar. X bar and y bar, because value of x bar, y bar is what? 3, 3. What is another point, everyone? Another point is y-intercept. Y-intercept means where it cuts y-axis. So where it is cutting y-axis at 2.1. Let's suppose 2.1 is this. So this is your second point here. Now we have got 1 and 2. We have got 2 points. If you have 2 points, you can draw straight line. If you have 2 points, everyone, you can draw straight line. So let's suppose I will draw a straight line passing through this particular point. Just assume that this is a straight line. Just assume that this is a straight line which is passing through these points. So now remember everyone, this particular line is called as line of best fit or best fit line. This is the basic idea behind linear regression. Line of best fit or best fit line. And as it's a straight line, even the nature of the straight line is always straight. It is not like that after some point it is going to be like this. Not possible. It's a straight line. And that's why it can give my answer. What was the question? If the rating given for bubbly part 1 is 3.5, what will be the rating given for bubbly part 2? What I can do is I can draw a straight line. I can draw a perpendicular line from line of base fit to this particular point. And from here, then I can project it to this y-axis. So with respect to this particular value, what is the value of y? Just assume that this is 3.2. If you want the accurate calculation, you can go and you can use the equation. So answer is going to be 3.2, let's say. This is what a method called as linear regression will do. In Python, when you implement this, are you going to do all these things? No, not at all. You are simply importing one method, everyone, and that is called as linear regression. That's it. This is what you are going to import. But what is going to happen in the back end? This is what I am trying to tell you here. Going and creating the model is just 2 minutes of task, everyone. Your job is just to go and import this. And just call it, create the object of it, and that's it. Your model will be done. We'll be going and we'll be doing it. Hands-on also will be doing it. But try to understand. This is called as line of best fit. And see, even I told you, line of best fit is a line which passes through dense area. It means the distance of that line from original data points is as minimum as possible. This particular distance, this particular distance will be as minimum as possible. What is the distance? See, this is original data and this is predicted value. The difference between this is nothing but what? Error. And error is also called as residual. Always remember it, okay? This is original value of y. This is predicted value of y. Y minus y cap is called as residual or the error. And ideally it should be 0. But it is not 0, right? So if you want to go and if you want to calculate the total error, everyone, what will happen? Here it is y. Here it is y cap. Predicted value. You will get some positive value here. Positive error, positive error. But here you will get negative error, negative error. And if you try to add all those errors, positive and negative are going to nullify each other. That's why everyone what we do is we try to take the square of the errors. So let's suppose this is D1. Let's suppose this is D2. This is D3. What we do is total error is actually calculated like this: D1 square plus D2 square plus and so on Dn square. Why the square is taken, everyone? Just to nullify the effect of negative value. Right? I hope you are getting my point, even. Remember this. This is called as line of best fit or best fit line. This is called as residual. Residual is nothing but the error. This is called as residual. And we take the square of the residual to calculate the total error, everyone, because otherwise positive and negative errors are going to nullify each other. Just to avoid that, we take the square. That's why this distance will be taken as square. Y minus y cap. Okay. Are you able to understand my point, everyone? All of you? Any question, anyone? At least are you people able to understand what is residual, what is error, what is line of best fit, and how do we make use of linear regression? Okay, others, I hope it is clear. Anyone, any question? Okay. Fine. So these things will make more sense, even in the next session, as and when we will go and we'll talk about implementation. Okay. So directly I'll be starting with Python, where we will try to see the implementation of linear regression. And in linear regression itself, we'll try to talk about some of the techniques which you are going to need not only in linear regression but other algorithms as well. I will tell you here itself. If you are good with, if you go and if you try to understand linear regression, logistic regression, and k-means, other algorithms you will see same techniques are used. Okay, so one by one we'll go and we'll talk about all those things, and we'll try to implement each one of them. Okay, so fine, all of you. This is what I wanted to talk about today. Maybe in the next session we'll start with the implementation of linear regression and we'll try to create a prediction model. Okay, fine. Thank you all of you. We'll stop here for today. We'll meet in the next session tomorrow.